Hello my dear students, welcome to the 9th standard physics class. Our first chapter is forces in fluids. Okay, so you must have studied in lower classes that there are three states of matter. Which are the three states of matter? Solids, liquids and gases. The properties of liquids and gases are almost similar. For example, both liquids and gases do not have a definite size, shape and volume. It assumes the shape, size or volume of the container in which it is taken. Okay, there are some more other similar properties also. So, liquids and gases together we can categorize as what we call fluids. So, fluids can be termed as liquids and gases together. Okay, hope you understand the concept or the word fluids. Okay, now consider two instances of life. First one is, take a water in a glass. Then place a razor blade on the surface of it. Okay, then what happens? You can say the answer, right? This is a very familiar example for you. This blade floats on water. Why it floats on water? Because the weight of the blade is very small. Now consider the case of a ship that also floats on water. Right? Is the weight of the ship is very low? No. Right? Weight of the ship is very large. It is made of iron. So, what is the reason for that? This can be explained on the basis of density. You must have studied density in lower class. What is density? Density is mass divided by volume. Okay, so if volume is very large, density is very low. To explain that or to understand that, consider 1 by 10. What is the answer of 1 by 10? 1 by 10 is equal to 0.1. Consider 1 by 100. So what is the answer? 1 by 100 is 0.01. So here see the difference. If the denominator is large, then the result is small comparing to this. Here denominator is 10. So the result is 0.1. Here the denominator is 100. So the result is small. Then it is 0.01. That means if denominator is large, that is here what is denominator? Volume. Volume is large, then density is small. If density is small, then such substances floats on water, because water has a density of 1000 kilogram per meter cube is the density of water. So, if the substances is having less density than water's density, such substances floats on water. If you take a block of iron with same weight of that of ship, then what happens? It will definitely sink, because for that block of iron, the volume will be very small. Okay, ship is very large in size. So, consider the height inside the ship, then it will be having large volume. So, density is small. Understand? Such less dense materials floats on water even if the whole weight is very large. Okay. Now consider another situation of life. Okay. Take a bucket of water in which an empty plastic bottle is placed, and you do in such a way that you just push this plastic bottle towards the bottom of the bucket. Then what happens? The empty plastic bottle will automatically come towards the surface of water again. Consider another situation of life, that is, draw a bucket of water from a well. Then you may feel that up to the surface of water, the bucket of water is having less weight, and if it is above the surface of water, then we feel the actual weight of the water, isn't it? So in these two situations, water is doing something on these two objects which pushes this objects upwards direction. Okay, so there is a force acting on the objects when the object is partially or completely immersed in water in upward direction. Okay, this force which is acting in upward direction on objects when the objects are completely or partially immersed in water is known as buoyancy. So what is buoyancy? It is the force acting on objects when the object is partially or completely immersed in water is known as buoyancy. Okay, our next topic is how to measure buoyancy. For that, consider a stone whose weight is to be measured using a spring balance. Okay, so if you measure the weight of the stone using a spring balance, if the spring balance is calibrated in Newton, then you will get the measurement in Newton also. That means it is the weight. If it is calibrated in grams, then you will get the measurement in grams. So to convert that into weight, then you have to multiply that with acceleration due to gravity. Okay, so here assume that this is calibrated in Newton. So you will get the weight of the stone in Newton. So if you weigh this stone using a spring balance, then in air, say you got 5 Newton. Then weigh the same stone inside water or in such a way that the stone should be completely immersed in water. Say the weight in water is 2 Newton. Then there is a difference in the weight of the same stone in air and in water. So why this difference happens? That you already studied that water helps in upward direction. That means there is a buoyant force or upward force acting on the stone when it is completely immersed in water. So that is why here there is a weight difference. So what is the difference in weight? 5 minus 2 is equal to 3 Newton. So this 3 Newton difference of weight is due to buoyancy. So buoyancy can be measured. So buoyancy can be measured by simply weighing the object in air and in water, then or water or any other liquid you can use. Okay, so buoyancy can be measured the weight of the substance in air or in that liquid, and that difference in weight constitute our buoyancy. So instead of a stone, you can take a metal piece also. Do the same. Say the metal piece in air the weight is 6 Newton and in water it is having 4 Newton. Then what is the difference? 6 minus 4 is equal to 2 Newton. So to measure buoyancy, it is enough to take the weight in the liquid and in air and take the difference of these two, then you will measure the buoyancy. Okay. So what we have studied today, Buoyancy. What is buoyancy? Buoyancy is the upward force acting on the objects when it is partially or completely immersed in water. Then how to measure buoyancy? Buoyancy can be measured by taking the loss of weight of the substance inside the water or any other liquid or in air. Okay, hope you understand today's class.